Okay, we pick up here with the algebra functions. We're basically going to be looking at sum, difference, product, which is multiplication, quotient, which is the division of functions. And they're defined here. So basically, if you have f plus g of x, it's equivalent to the f of x function added to the g of x function. And likewise for the difference, product, and quotient. You can see how that comes to exist here. The only one that has a condition is g of x cannot equal 0, because remember we can't have division by 0. So that's the only other thing we have to keep in mind. These are fairly basic concepts. So this is the f plus g of x, which means we can add our f of x function, then our g of x function. So f of x is given to us right here, 2x plus 1, and we're going to add that to our g of x function, which is x squared plus x minus 2. And then it's just simple addition, so adding like terms. This would give us x squared plus 3x minus 3. And I wrote this down wrong, so that's minus 1. So make sure you make that adjustment right there. So when you add them, you get x squared, then 2x plus 1x is 3x. Makes it sense now. And negative 1 minus 2 is negative 3. So we're looking at this solution, and we want to now know the domain, and we're going to use our previous lesson to help us do that. It's just a polynomial, so that our domain is going to be what? All real numbers. Good job. All real numbers. So that's negative infinity to positive infinity. B is f minus g of x. So basically we're going to take our f of x function and subtract the g of x function. So from the previous screen, f of x is 2x minus 1. Now we want to subtract. You have to be careful here. I would suggest you put parentheses on the g of x function, which is x squared plus x minus 2, because if you don't, you will forget to distribute this negative out for subtraction. And this is probably actually the most error that most problem that most of the students make error on is the subtraction one out of all 4 of the operations, simply because of that reason right there. So now we want to I'm going to carry this down, and then I'm going to say negative x squared, distribute out that negative, minus x plus 2, and then we add like terms there, and we will get negative x squared here, 2x minus x is just x, negative 1 plus 2 is just 1. So this is our answer. And the next thing we're asked to do is give the domain. The domain of this is going to be all real numbers, because it's just a polynomial, so it's negative infinity to positive infinity. Okay, our f times g of x is the same thing as our f of x times our g of x, so we want to write that. F of x is 2x minus 1. G of x is x squared plus x minus 2. Now what do we have to do to multiply this out? Usually for binomial times a binomial, it's a FOIL, but we have more terms. It's a binomial times a trinomial. So basically we're going to take this first term, distribute it, and multiply it times everything, and then we will come back and take the second term of this and distribute it, add like terms after that. Okay, so after multiplying these out and then adding like terms, we get this answer, and now we need to determine the domain, which is, it's a polynomial, so yes, once again, our domain is negative infinity to positive infinity. And we have division, so f of x divided by g of x is the same thing as writing our f of x function, over our g of x function, which is x squared plus x minus 2. Now, what we need to do is this is the simplified version of those two functions, division of those two functions. But the thing that we're going to actually have to do some work on is going to be our domain. It's not just all real numbers as before because we have a radical. So we need to set our denominator not equal to 0. So now, just for determining our domain, x squared plus x minus 2 cannot equal 0. So go off to the side, factor that out, and then let's figure out what our domain is. Okay, so after we factored it, we bring that information back over here, and now we're ready to set this one not equal to 0. And then this factor not equal to 0. And I'm sure by now you're familiar with, so x cannot equal negative 2, and x cannot equal positive 1. Now we said if it helps to see a sketch of this, if it helps you write interval notation, that's a negative 2. It means it can't be this, and it can't be this, but everything else. So naming this left to right, that's going to be from negative infinity to negative 2, parenthesis, union negative 2 to positive 1, union, and then from 1 to infinity. So our domain for this part D is here. Now we have let f of x, which is the square root of x plus 3, and g of x is equal to square root of x minus 2, and we want to add these two together. So we just simply square root of x plus 3 plus square root of x minus 2. There's nothing we can do to simplify that, so this actually is our solution for part A. Part B says find the domain. Since we're dealing with a radical, we don't want the value under the radical to be negative, so we want to say x plus 3 is greater than or equal to 0 for this first term, and x minus 2 is greater than or equal to 0 for the second term. And we solve these. And we have both of these inequalities. So if I was to draw this on a number line, just to help me out, so I have negative 3 and positive 2, this represents a bracket greater than, and this is greater than or equal to 2. What portion of our graph satisfies both? The black part, which is going to be in interval notation, our domain would be bracket 2 to infinity. Good. So it's satisfied. The black is what satisfies both parts.